Hi everyone. Today I'm going to show you the basics of Python using Jupyter notebooks. I hope by now that you have installed Anaconda from the website. Once you've installed Anaconda, on a Mac you can open the terminal, and on Windows you can open the command line, and using the command line all that you have to do is enter Jupyter notebook. Sorry, as for the spelling mistake. Jupyter notebook. The Jupyter notebook will open in the browser. Here's my Jupyter Notebook terminal. This is what it looks like. You see the file structure over here. Over and you can navigate to the folder in which you want to create your Jupyter Notebook. For now, I'm going to create a new folder. Here you can see it as untitled folder. You click rename. I'm going to say um, something that is relevant to the workshop. So I'm going to say this workshop for now. Open it. I click new on the top right, see Python 3, and here we go. This is a notebook. You can name your notebook over here on the top left. I'm going to rename it as something like test1 because we're just running a first test set of scripts. This code box is where you enter your code and which is where you're going to run your code from. The advantage of Jupyter Notebooks is that you can run the code and see the output right there. This helps you keep track of your code and also helps you create your code in smaller, more manageable steps. So for example, my code is going to be a simple code of saying that A is equal to 2, B is equal to 2. I'm going to define a new variable called C, and I'm going to say C is equal to A plus B. I'm going to say print C. So as expected, I get 4. By the way, to run the code box, you have to press Shift and Enter. So you move your mouse to the code box, and then you press Shift Enter. It runs it. Over here on the top left, you see this number turning from 1 to 2. This means that it has run the second time. If I write another code box over here, for example, C is equal to 2 and D is equal to 2, E is equal to C into D, print E, we again get 4 because 2 times 2 is 4. And here you see this code cell is numbered 3 because the first one was run on this box, the second one again was run on this box, and the third one is run on this box as well. So the advantage of such an interface is that here, for example, I have already calculated the value of E. Now I want to say calculate a new variable, which is E squared, so I'm going to define F, which is E star star 2, which is how you write the E squared in Python. And I run it. So I don't have to redefine what E is over here. It remembers it from the previous code block. And if I say print F, as expected, it's going to be 4 to the power 2, which is 16. And that is the biggest advantage of Jupyter Notebook. You can have these little manageable code blocks, and at the end of each of these blocks, you can ask the values that is stored in each of these variables. For example, I can ask what A is equal to, and it says 2. The other interesting thing about Jupyter Notebook is that the last line is actually displayed as the output. You can just call a certain variable and that will be shown as the output. So for example, if I say B, it says out 7. So it directly displays what the output or returned value of B is in this format. So the basic data structures in Python. And just before moving to the data structures, I'd also like to say that another thing that you can do with Jupyter Notebooks is Markdown, which is that you can make, say, the headings. And uh, so here I've created a heading called data structure. The way I do it is by going up, changing the cell from code to markdown. I put 2 pounds. These 2 pounds indicates a heading. I'm going to give you resources which tell you what are the different things that you can do with markdown. But basically you can stylize your scripts, your fonts, and use that to comment out your code and give it more structure, so that someone else who's going through this, or even you, a future self of you that's going through the same notebook, can understand what you were thinking while doing this. Anyway, so talking about our data structures, the most basic data structure you've already seen, which is the integer in these above blocks. I have just said it's equal to 2, or it's each of these are just integers. Integers could be compared against, say, floating point numbers. For example, I can say x is equal to 1.05. And here, this is not an integer. This is a floating point number. Floating point numbers are numbers with decimal points, which go beyond the precision of 00. Um, then there's strings in Python. You use single or double quotes, and then you can write any string in it. So I defined a string called st, which is this is a string. If I ask what st is, again, I needn't print it. I could also print it. It gives the same output. The only difference is with the out, as uh, as shown earlier. You could also define a list. A list is defined using square brackets, and then in the square brackets you mention all your elements. Now, you might have noticed that I didn't write the same elements down, like the same data structures inside the list. And that is one of the advantages of lists, that they don't need to be of the same data structure. In fact, I can define, say, a list 2, which is a list of lists. So this is a list which contains 1 comma 2, 2 comma 3, and also say 2 and also say 1. So it's pretty unstructured. The only thing is that you've got various elements at various indexes in this list. So the first one over here is 1, second one is 2, third one is 3, fourth one is 4, fifth one is 5.7. In the second list, the first element is 1 comma 2, the second element is 2 comma 3, third element is 2, and the fourth element is 1. Now, the way you ask the list, the thing about a list is that it helps you, it can be indexed using square brackets. So you press square brackets and then you enter the index number that you're looking for. Remember that indexing in Python starts from 0. So which means that the 0th index points to the first element. So the first element in our list 1 is 1, so it returns 1. And the second element in this is the one in list 2, the second element is 2 comma 3. You can also index a certain subset of the list, which you can access by this, which is or something like this, which means that give the element on the index 1, which actually means the second index, and all the elements between 1 and 3. So you get 2 and 3, which is what it returned over here. Now, in Python, quite often you get objects which are returned uh, as some operation that you've done on another object. And you may want to figure out what the data structure is of of what you're getting at the end of the operation. To do that, what you have to do is say type of whatever variable you're looking for. For example, I can ask the type of A, as we had defined earlier. And as you might have expected, it's an int stands for integer. I could ask the type of x again. It's a float. I could ask the type of something like this. It's a list. So this is going to be important because at times when data structures get more and more complicated, you may just want to know what the type is of a certain data structure. And then that might be useful for whatever operations you want to do on it. Now, Python is also what's called an object-oriented programming language. The thing about object-oriented programming language is that these data structures have certain internal components to them. So, a certain function might be defined as a property of this data structure. For example, let's say, and I know this because I've checked this earlier. Let's say I want to add a new element to list one. I want to add, say, 6.2 to it for whatever reason. I'm going to say list one dot append 6.2. And when I see list one, it has added 6.2 at the end of it. So this function that you've put over here has changed list one, and now it has updated it, it has appended, it has increased the number of indexes and added 6.2 to it because um, that's what this means. That's what this does. Quite often in Python, you will see that there are various um, functions that you can get as a part of that data structure. And the way you access them in Jupyter Notebook, and this may not be the same for all operating systems, and I know it doesn't apply for all browsers, but for Mac OS Mojave on Chrome, you can just say list one dot and press tab, and then you start seeing all these properties. And you can quite often guess what these things mean. So for example, append is something that I've already showed you, but reverse will be something that reverses the order of the elements in this thing. So each of these data structures can have, let's see what int has, for example. So int can have something like conjugate, bit length, denominator, from bytes, numerator, and so on. We don't need any of these things for now, but in a future problem, you might find that these things get useful. Usually the integers are not very useful in terms of these things. But floating point numbers, for example, can give you interesting results. Now, I'm not too sure what as integer ratio does, but there's always Google to help you out with that. Moving on. The next thing I wanted to show you in Python was conditionals. So quite often in programming, and I'm sure anyone who's programmed before, or even if you're new to programming, you'll quickly come across a scenario where you don't just want to run the same set of code, but you want to run the code conditionally. You want to run the code if something is met. So for example, we know that a is equal to 2, and I now we know this. And I say that if a is greater than 2, please print a is greater than 2, something like that. Else, print a is not greater than 2. So if I run this, you get a is not greater than 2. But I could change a's value to 3 and run the same code once again, and now you get a is greater than 2. In this example, this may not seem very useful, but it could be useful. For example, um, I define something that's more complicated. Say I define something like should multiply as another variable. So I'm going to say should multiply as true, for example, over here. So this means that so I'm trying to define a function which either adds two numbers or multiplies two numbers depending on whether should multiply is true or not. So the way I would do that is I would say I'd take my first two numbers as say a is equal to 2, b is equal to 2. I can change this block, so I'll leave that over there. I go to my next block and I say if should multiply tab is autocomplete is equal to true, then c is equal to a star b, else c is equal to a plus b. Now I just realized that as expected, c will be equal to 4. However, this doesn't show anything about the function because 2 plus 2 and 2 into 2 both are equal to 4. So I'm going to change 2 to 3 and I'm going to say should multiply is still true. So I'm going to get c is equal to 6. But let's say that I would change my should multiply to false and run the same block once again. You're going to get 5. So as you can see, the good thing about Jupyter notebooks in general is the fact that you can reuse code quite often. You don't need to keep rewriting the code and running the same functions. You can just run that code once again by changing initial parameters in another block, and it very neatly delineates and separates all of these things so that you can do it. The next thing to know in any programming language is loops. Loops Loops are often used to run the same set of code several times. So there are two major loops in Python, and the syntax for both of them are as follows. The first loop is the for loop. So I would say for I in a list. So for me, I've already defined a list 1. I could now do something with I. I could say print I, but I could also say print I plus 1 for some reason. Before running this code, I'm not too sure what my list is. So I just take a quick look at my list. My list is 6.2, 5.7, 4.4, 3, 2, and 1. So I'm going to expect 7.2, 6.7, 5, 4, 3, and 2. If I run this again, I get what I expect. The advantage of each of these things is that you can often manipulate these objects in a certain way. For example, I wanted to create a new list with each of these elements inside it. The way I would do that is say new list, which is my new variable. I'm going to make it an empty list with nothing in it. And then I'm going to iterate over the elements of the other list, list 1. And I'm going to say new list dot append I plus 1. So now if I take a look at new list, it has 7.2, 6.7, 5, 4, 3, and 2, as expected. You can further define more complicated things in these loops, and that is something that you will necessarily come across. There's one thing that I'd like you to pay attention to the syntax over here, which is the colon and the indent. So the syntax in Python is after you define your loop condition, you write a colon, and then for as long as you're indented, it means that that section of the code is within your loop. If it's not within, for example, I'm going to say print a dot. So this would print 7.2 and then it would print a dot, and then it would print 6.7 and then a dot. However, if this was not indented, it would mean that it fell outside the loop And then you'd have 6.7.2, 6.75432, and then the dot as follows. So it's important to be mindful of where your indents are and where your blocks end. Again, over here, for example, I also had the same syntax where you have your colon and then your indent. And that is exactly how Python runs. One other important basic element of coding, which I'd like to cover in this video, is functions. Quite often in coding, you want to run a certain function several times. So for example, I just want to run the function that takes one number, multiplies it by 2, subtracts 7, and then divides it by 5. So I'm going to say define strange function, and this function was just something I came up with. So parenthesis is where you put your inputs, press colon, you get your indent automatically, and then you say a is equal to a divided by 2 into 2 was what I said. A is equal to a minus 7, and then a is equal to a divided by 5. So I have a function that takes a certain number, doubles it, subtracts 7, divides it by 5, and then what I could do is just print a. But that we don't just want to see it, we wanted to return a. So this is what my function looks like. So I'm going to just say strange function of 2. So this will be 2 into 2, which is 4, 4 minus 7, which is minus 3 divided by 5, which is something less between like 0 and minus 1, which is minus 0.6, which is minus 3. Yeah, minus 3 by 5. So that's how you define your functions. If you want to define a function with more variables in it, then you could. So this function is going to do something pretty stupid, which is raise it to the power of n plus 1. So I'm going to write the name of my function like this, raise to the power n plus 1, a comma n, and I'm going to say return a star star n plus 1. So I take two inputs n, so I say raise to the power of n plus 1, which is 2 comma 3. So I'm going to expect 2 to the power 4, which is 16, and there you go. You get 16. So this is the most basic part of Python programming. It's the most important fundamentals that you need to know. To go over everything once again, I showed you the interface of Jupyter notebooks. I showed you the different data structures that are there in Python. I showed you lists. I showed you how to index lists. I showed you how to inquire about the type of a certain element. I showed you how to use various inbuilt functions within a certain data structure to modify it as required. I showed you conditionals, which show how if-then statements are coded into Python. And then I also finally showed you loops and functions and the syntax for each of these. I hope all of these things were clear to you, and we shall continue in the next lecture.